All attendees are in listen-only mode.
Good evening, ladies and gentlemen. Welcome to Techgig webinar series. The topic for today's session is Static Analysis, Abstract and Concrete Interpretation. And we have with us today Malini Mohan Kumar. Malini has over 13 years of experience in the IT industry that includes development, testing and project delivery management. She has handled different clients and has been in quite few roles like QA manager, process lead and COE lead. She has worked on a wide range of technologies, Web 3.0 Internet applications, ERP, CRM, gaming, mobility apps, cloud and web portal SharePoint applications. She has done quite a few process implementation on test methodologies, including V-model, agile and test-driven development. She is a regular contributor at software testing events and other IT tech summits. So before I hand over the session to Malini, just quick tips for all the attendees today. Malini will be taking us through her presentation for the first 15 or 20 odd minutes today, and she will be taking up questions between 5:20 and 5:30. For all those who would like to share questions for Malini, request you all to post the questions from 5:15 p.m. onwards. So without any further delay, I now hand over the session to Malini. Malini, over to you.
Yes, thank you so much for that intro. Hi everyone.
Malini, you are not audible.
Is it audible now?
Yeah, this is fine. Please carry on.
All right. Hi everyone, good evening. Thank you for joining Techgig webinar. Hope you find this presentation useful. I'm going to go through with this presentation around 20 minutes and then we will go with a Q&A session. Before I quick start, I see quite a number of freshers have been joined this discussion, so benefit of their perspective about the static analysis, I would like to start with what is static analysis. The static analysis is a program analysis techniques. Everybody says testing techniques, but obviously yes. It's a program analysis technique that allow us to evaluate the application without even executing the code. This is what it is, you know, in the definition of static analysis. So I have seen somebody call, put forward that what is dynamic analysis. Then yes, of course, the dynamic analysis is also a program analysis technique, and it's called testing technique even, and that is also even allow us to evaluate the application during the runtime. So this is the difference between the dynamic and the static analysis. Why did I choose this topic? This is like I'm trying to bring a little awareness among the testing professionals. As you all must be doing all the static analysis, but little awareness about what is inside the static analysis, how effectively we can use and where exactly we can use to see our stress level, little bit low. Whenever the releases are going, we all upfront running and finding all the hidden bugs. But if at all we are using these kind of techniques, upfront we'll find a bug and it will easy down our process, as well as we can deliver a good quality. Right? Okay, I'm going to the little bit of agenda for you. We will discuss about the importance of static analysis tool. And definitely we will discuss about abstract and concrete interpretation and analysis. And this abstract and concrete analysis will have the techniques of bug pattern matching, data flow analysis, model checking, and program analysis. We'll touch base each one of them. And I'm going to show you the small snippet of codes and how this static analysis tool is going to help us finding the hidden bugs. If at all I'm going a little fast, please let me know so that I can slow down a bit. So to quickly start with, I just wanted to see why we generally find bugs. So there are major areas. The 5 areas that I found. It's according to my experience that I found these areas are really crucial to bring loads of hidden bugs. First, in the initial stage itself, isn't it? When you're going and collecting a requirement stage, and when we are doing a lot of back and forth with our client, there are a lot of verbal and non-verbal communication that goes, like back and forth. That's when it starts a lot of gaps. That's where the bug starts, walking through. And then when we are setting up the requirement in a bucket, we are setting up the priorities and we are setting up the complexity, that's when there is a few more bugs will walk in. And then we'll start implementing, and then we'll pour out with a lot of change requests. We'll have a set of bugs, and then you all are with the crunchy time limits, and we'll be wrapping up with a limited period, and we have to deliver with the quality and all that. We will be compromising the review process maybe. So that's when we will allow few bugs involved, and definitely the coding factor is that is the area that is the 20% off. But if you see the communication, the complexity, the change required, crunchy deadlines, all these are the major contributor towards the bug. Then the coding, of course, yes, we as a team, if at all we are kind of adopting few techniques and the process, definitely we can overcome. So moving towards the fighting, okay, generally we always will fight with the hidden bugs, right? So I found out in a general, when we discuss with the developer and testers, always we say this, these are all the main thing that is, sometimes it just pops up in the production and the staging, not in the development area, the staging and the production, improper input validation, memory leaks, initialization, authorization, all these are security checks, all these things suddenly pops out and then walks in very comfortably. It's not according to me. If you go to this, the below link, that what I'm talking about, common weakness enumeration, that's where I found out whether these items what I specifically mentioned, I went ahead and I checked this link. Yes, of course they have put it across in the 25 common programming bugs. It is there. So you can as well go and check to find out, and you will learn to write test cases around this programming bugs. This is very interesting list what they have. So moving towards to the static program analysis, right? What is program analysis? Is analyzing the program and analyzing the description about the program and trying to interrupt the program. These are all the what is a general thing. So what is static program analysis? This is what Wiki says, right? As I mentioned, without even executing the program, we will be running through the code, and we will be analyzing what it is like. Predominantly, is there any missed out mistakes that we can quickly jump in and fix it. So the SPA is nothing but static program analysis that will give us a quick feedback, and it's very easy to execute, and definitely is a very meaningful and adaptable technique that will always allow you to deliver a good quality product. If at all you don't have any strategy or plan, please definitely go ahead and add this in your testing plan. I know that we are, as a testers, we are all moving towards to the SDET right now. Software development, engineering, and testing. That's how we are all, moving towards to that path. So this is the ideal technique that will allow you to grow in your SDET path. Moving towards the next slide, that is, anyway, we have discussed about little about the static analysis and the dynamic analysis difference, right? As I mentioned, dynamic analysis is a testing technique, program analysis technique that will evaluate of an application during runtime, right? So the static analysis is the testing technique, program analysis technique that will evaluate of an application by examining, that's what I told you, without even executing the code. So these two are really a complementary because without single approach, I don't think so we will go and find a lot of loads of bugs. So this dynamic and the static approach will go, it's supposed to go hand in hand. So coming towards to the static analysis, because my focus area is static analysis. What it will do? Will it allow me to calculate the complexity? Of course, yes. Will it enforce the coding standards? Yes. Will it analyze the structure and dependency? Of course, yes. Will it identify any anomalies in the code? Of course, yes. These are also to calculate the complexity, to enforce coding standards, to analyze structures, dependencies, and to find anomalies. Definitely we will work for the static analysis. One other the quick thing that I wanted to specifically mention about static analysis, always developers and the SDED and white box testers and the build managers, everybody, we will raise our hand and say that it takes a little longer period when we incorporate this static analysis technique inside our process, because that's the only disadvantage part we can definitely overcome. And there are integrated development environment, that is IDE. It's coming up with the inbuilt static analysis tool these days. So in the slide, if you see that I've quickly given a kind of a simple example to understand, as a fresher, anyone is here, so they'll be able to understand what is the difference between the static and the dynamic analysis, right? So the static analysis tools, it's like, everybody say generally used by developers as part of the development, and they just immediately debug and see it. Being a SDED, for me, it did help me quite a number of times. I use CheckStyle. So whenever we do a kind of component testing, we extensively use the static analysis tool, which really helped. So I think we all, being a tester, we have to move out of our comfortable zone and take up this opportunity to expand our knowledge, and by using all these techniques and tools to see and help the whatever team or company or to deliver a good quality product to our clients. So moving to the next slide. So why static analysis? Why we are talking about this particular technique today? Why, in the sense, percentage level, the 60%, we are in the ignoring state, that is the static analysis tool. We are quickly moving towards the dynamic analysis. So as a testing professional, if we are focusing on the static analysis tool, as we mentioned, we will definitely cover a lot more verification test cases while building the, while setting the design guidelines and while building the code itself. It's the main reason we are focusing on it. And can cover code, definitely it is like, one low level, like dynamic analysis is the higher level, the static analysis is the lower level. Whenever we are missing something in the static analysis, definitely we can go back and find out the another level of mistakes what we missed out in the static analysis, the dynamic analysis will capture. As I mentioned, we can run this with the IDE, just clicking a button these days. That's a built-in thing is coming in. Peer review, path review, and pairwise review, code review, all these reviews were excellent. There is no doubt about it. But that is not sufficient. That we have to additionally give importance, see what are the other techniques that we can adopt and reduce our the bug size and density, that we call that as, right, effect density and all that we can reduce it. And definitely catch usual obvious mistake. Yes, that is in my experience, I've seen that there are few cases we found unusual bugs and things like that. That will happen, miraculously with static analysis too. Sometimes dynamic analysis will catch the unusual bugs too. So that's what I said. This is complementary factor. These two go hand in hand. So what the static analysis is not actually. So manually checking is just taking a code and checking some braces open, close braces, or HTML tags open, close, and full stop comma. Is it the only thing, or we are going to just checking the object, the properties are set while we do it in the model checking? Is it the only thing that is a static? It's not. So what I wanted to show out of this example here is possibly what you can do is the buffer overruns. The example is talks about the buffer overrun. Can you see that it's just a 4-line code? We set the variable for the buffer around 1000, and then are we safely initiating the variable that is I? Yes, we are initiating, that is in the 3rd line. I'm so sorry, if I have a whiteboard I can just quickly show you and mark it and show you there. And the 3rd line we are safely initiating, and if you in the last line, that is in the red one, isn't it that is the buffer overflowing? That's the kind of a bug the static analysis will help you to find out. So this is possible, actually, this is possible. And not only that, the manually going and checking, it's not that alone, it gets into that level of memory leak sometimes, and then why I'm using that sometime, I'll come and tell you why I'm using that. But dynamic analysis will help you more than the memory leaks. Static analysis will help you with buffer overflow and things like that, right? So this kind of a overview I just wanted to give you here. Static analysis, it's a synonym that I found out when I was there reading about articles and all that. Approximation. This is how they call it as a, what is approximation? Approximately my memory configuration is set or not. Approximately my all that operations and parameters and data flow structures and general schema, everything approximately set with the predefined rules and regulations. Is it approximately set or not? That is how the static analysis works. This is called static analysis. So we don't need to, couple of days we always keep the estimation to check the reviews and everything is set, configured properly or not. This can happen then and there when you are doing the module level, code level, or low level, small chunk level. When you are setting, you'll be able to do this with this technique. All right, so we are done with the why, what, when, all this static analysis tool. Then we are moving to the one level down, that is the abstract and concrete interpretation, right? So I've listed out 4 questions for you there. What is program semantic, what is program analysis, and then the interpretation. So the program semantic is the top boss for us. So the top guy, that semantic analysis where we will interpret, describe the program and what it execute, what it can do, and all that. That is what it is all about, semantic. Right? Semantic is, I just written some 2 lines that you can as well read it. So it's a top guy for us, and then the semantic will allow us to do a set of program analysis. So what kind of analysis we do? Static and dynamic analysis, right? So we are picking the static analysis today. So the static analysis will consist of 2 interpretations, that is the abstract and concrete. In this, the concrete is the top guy here. So the static analysis will happen in 2, but the concrete interpretation will sit top over and above on the abstract interpretation. That I'll tell you why that is. So we will see what is what here. So what is abstract? What is abstract interpretation? So if any one of us just say -1 into +1, how much it is. So immediately we'll all know 1 negative, 1 positive, how it is. We can derive immediately without even thinking anyone can answer. It's a negative value. That is the quick derivation, that is predefined rule. From the predefined rule, anyone can tell us that is the negative. That is called abstract. The concrete, it always goes with the arithmetic calculation. You have to prove and you have to bring in a lot of value, data points, so that's the concrete. So this is a very simple abstract and the concrete differences. That's where I explained in detail, and I know that it's a text are overflowing in this slide. Excuse me for that. So you can read through and you will definitely understand the difference. So going back to the concrete, when I say concrete, the concrete will have a very concrete semantics, that is the arithmetic layers and then the syntax layers. Everything will be there on the top layer. From there, excuse me, the static analysis, the abstract tree structure will be derived from the concrete layer, because this is like a predefined restricted rules that's been defined out of the concrete semantics, that is the abstract. So this abstract interpretation, it is a symbolic execution. Yes, it analyzes the program in a symbolic way and tracking all the symbolic values instead of actual values. So yes, without executing, the program can be interpreted. Definitely, that is what the static analysis. Nowadays, all the non-commercial tools and the commercial tools, open source tools and all that, they are the static analysis tool use this abstract interpretation. Moving to the next slide. So the abstract interpretation, this is the quick overview about the abstract interpretation. We will be collecting the specifications, what it is required. We will be looking at the concrete semantics, and we will see what is our need, what is our specification. Okay, these are all the set of the rules and regulation I want for this kind of a program analysis that I'm going to fix. So on top of the concrete semantics, I'll be listing out my specification, listing out my rules and regulation, and I'll construct my abstract semantic over and above and apply my algorithm to come out with the static abstract interpretation for my program analysis. So this is the overview about the abstract interpretation. It's a simple collect specification, construct your rules and regulations, and apply your algorithm and execute and see. All right, I think we moved to the bug pattern matching. I just want to quickly recap. We have seen what is static analysis, what is the difference between dynamic and static, and why static analysis, what static analysis can do for us, what it cannot do for us. And then we have covered the program analysis, program semantic, and program analysis. Under the program analysis, static and dynamic. Inside the static, we have seen the abstract and concrete. And we understood the abstract methodology and how we are specification construct and then the algorithm. We are developing our own predefined tool for static analysis. Is this the only sufficient? No, we need additionally not only the rules and regulations, we have to define the algorithm with the techniques. So how it is going to happen? It is going to happen with a few techniques that is called bug pattern matching, model checking, and program querying. All these techniques we are going to see it. So what is bug pattern matching? It's simple example that I have given here, operators. So maybe a few of our folks in this discussion would have experienced the C programming and the C++ programming. If not, the testers also aware of it. The operators is equal to and the double is equal to, right? So these are all the operators bug pattern matching. You will be defining the operators based out on your program semantics, whether you're writing a C, whether you're writing a C++, whether you're writing a Java, whether you're writing a .NET. So I find a lot of very good research article around the bug pattern matching. The Java based bug pattern matchings is very huge list of bug pattern matchings is available that you can take the list and incorporate into your algorithm. .NET, I found it very little, but it is very interesting articles are found. I would recommend each one of you to please go and read all this, dwell into that article and see what is that you can do. And definitely for a tester, you can collect lot of the patterns, the matching, and not only the operators and things like that. There are many more things are there. How to handle the null references, how to handle the pointers. If, as I said, the C++, the pointers, the linking concept with the bug pattern matching, it is awesome concepts are around, so you can definitely download and see it. Alright, I'm coming back to the presentation. So what we are talking about is the bug pattern matching is these kind of a techniques algorithm, it gets into the algorithm for you to run through the static analysis. So you will be able to define your own bug pattern techniques methods. You'll be able to write on your own, or some tools, it's like commercial tools, that is predefined set of rules and regulation they are giving you. It is a bit costlier side, but it is definitely, no need to spend much time to write it on your own automatic static analysis tool with all these techniques. These are coming. So if you see that I have listed out all these tools are available for you. Gimple, PVLint, FlexLint, FXCorp, C#, all these tools are providing this bug pattern matching techniques. You can use this, integrate with your IDE, and then you will see that what it can do. You will see the miracle what happens, right? So I've given you the advantage and the disadvantages of this bug pattern matching. The advantages, yes, if at all we have a very quite big, huge, large code base, definitely this will help you. And partially you're like writing a program and you want to check all this, the operators, syntax and things like that, you will definitely use this. I heard this disadvantage, and I also found in Google and reading and then discussing with few developers, they told that this is the one disadvantages that they have mentioned. It's not good at finding errors such as null references or dividing by 0. I don't have any experience in finding these kind of a things, so I will leave it with you guys. If at all you guys find this disadvantages, yes, true, please get back to me. That would be great help to me also. The one other technique that is, one is the bug pattern matching. Another one is the data flow analysis. This is just, I have randomly I picked it from Google again. I'm not able to pull out from my real thing. So this is available, so I just picked it to showcase what is the data flow analysis. So data flow analysis, when you define your, enforce your design and the framework, when you're designing your architecture, whether it is a loosely coupled architecture, whether it is tightly coupled architecture, what it is all about, when you define your flows, right, from downstream, upstream, all that, when you will define the next level is data flow analysis. So you will get into this application model. That's how you are seeing the flow chart. I'm not going to get into each one of it. It is very easy to understand. So if you see that there is one arrow mark, that is a generated data structure. So that's where I'm going to concentrate. If you see in your right hand side, there is the data, how it is enters, how it is being like manipulated, how it is being flow back and forth, and then how there are dependencies. These are all very important. How it is getting optimized, how it is being looped, how we are calling the factor. These are all very important. This is the data flow analysis where we have to check lot more factors. This is where the null pointers, this is where the memory leak, this is where the initialization, reinitialization, dereferencing, closing, all this kind of things that we have to put in all our focus and then set in the data flow. That's the data flow analysis, right? So everybody says the data flow analysis is only thing that can happen in a runtime. If you don't execute the program, you will not even see how the data is flowing from one end to the other end. I see that it's okay that it cannot happen, but in the static analysis, definitely you will be able to see the pointer initialization. That's what I mentioned, right? The references, the path, how the value is being interacted between the paths, whether the variable is still null or referenced, re-referenced, what is what. These are all the things can happen with the static analysis, not only with the dynamic analysis. So there is a tool that applies this technique, that is the Findbugs as a tool. This tool will perform the bug pattern matching as well as the data flow analysis to detect the problem in early stage. So the advantage, optimization and efficient code generation. And this is again disadvantage. Developer says doesn't gather info based on the semantic of the programming language. It is not very effective. Find bugs. Find it effective in finding bugs, but if you specific to the data flow path and there's still null value pointers and references, it is not that effective way of, but it will find. It is not that 100% effective. Maybe this find bugs is they are still working on it, but we will see. Definitely it will help us to find these kind of bugs. Moving to the next slide, that is called model checking. In the early stage, couple of when we started, I was talking about it, right? Model checking. So model checking is this automatic technique that verify the correctness of the object properties and all that. This is generally a very expensive approach. That is comes with a very commercial tools so far. I haven't experienced any open source tools that is extensively giving this model checking. If you guys come across any best tool, please suggest, that will help us. So this is the property. Automatically this technique will allow you to check and verify. It verifies the object behaviors and things like that. It is very helpful when we are going with a very extensively migrating projects and all that. They need this model checking techniques. Because I have seen one other project when we are migrating the code from one technology to the other technology, this model checking technique is really helped. So the tool, obviously JPF, I never use this tool. I'm like having a less knowledge on this tool, but you can definitely check it. Explicitly construct trait model to check symbolic approach BDD. Advantage, definitely it finds bugs better than the conventional testing, and there with a conventional technique of testing everything manually and things, but this tool, definitely DDF, is really a good tool to find out when you are running programs integrated way, continuous integrated path and concurrent stuff. This will give you definitely a scalable solution to fix all your scalability issues. And then when moves to the disadvantage, this is one thing always people say is the expensive approach. Even I do agree. I've seen it. This is a time-consuming factor that is I never experienced, so I'm not too sure. So this is just a theoretical statement that I have placed. Time and resource consumption as the major disadvantages. And this model checking, the technique is available in Ndepend, SQL, Prolog, Datalog, J transformer, and Cultivate tool. These are all the tools is definitely having this model checking. And then the last technique that I have picked is the program querying. This program querying is, I think most of us, we all aware that unused fields or the try-catch methodology, try-catch-throw methodology, when we are implementing that the error handling stuff, and if loop blocks when we are closing it properly, how it is. These are all the program querying techniques that is predefined set of rules that is being implemented in the static analysis tool. These are all the list of tools that supports the program querying. And the link that I below given, this really in detail talk about the program querying languages where you can go and find more details. So static analysis, like different. This is not particular to one technology, that static analysis tool. It's different with Java, .NET, as I mentioned. So Python and all. We will pick up a few sample snippet and then see how the static analysis tool, how it is going to help us. So this is a Java code. I have picked it. So this, we will see that what is the expectation, what is that it is going to print. So I have a class, long-val is the class, and I have a public function static void. There is a string, and long1, and we are like calculating, and then we are printing the value, right? So the long L, it's supposed to print me 11. So I'm running that static analysis tool. It is saying 1. Why not 11? So you can go back and see, we are just running through this, and I'm running the static analysis tool. So it is showing me bug, long while Java, this is maybe L is used instead of 1 at the end of integer constant programmer. So this is how the JLint will capture and let me know, though I'm a little bit back and forth and going with the slides. So if you see that long L is equal to 0 into 1, that is not 11, that is 1 instead of 1 that went to L. So it's captured the bugs and show you. So these kind of, I just picked very minimal, very like a basic level of coding, and then basic level of what I can show to, because there are a lot of freshers and then very new to static analysis tool people are involved in this discussion. If you are expert, you will definitely understand what level of the JLint can capture, and then we can fix up the mistakes. So these kind of things and all, it is possible with the JLint. So I'm introducing the JLint here. It will capture all the inconsistency, and it will walk around the class files. If you give the certain class files, and it will synchronize, and it will show you the issues, synchronization issues, and it's very easy to use. You can download and you can run through this. So I picked the Python code. How this is, because if you see this code, if you run through, there is a import program that is one function or class or something is we are defining here, and then we are writing a class with the parameters, and what we are doing here, we are checking whether we are having the window platform or not. So when you're doing a code review, you just go here, yes, everything is right, but the Python static analysis gave me 4 errors. One is import module, that the module, whatever the sys module, the program that I talked about says, that is not available. No global platform found. I think, yeah, red color ones, you can see it, that this is, that is not used, and the platform, sorry, the platform, no global platform found, and then invalid arguments, and so on and so forth. You will be able to see all this bugs in the Python, the PyChecker. So the PyChecker, you can just go and download it in the below link, and it will give you set of rules. This is just, I picked 10 or plus, but this can provide you more rules and regulations for you to check and fix it up then and there. These are all the immediate feedback that you will get it once you execute. There is one other concept that I'll always hear from on the SDET, that is the false positive. The false positive is, as per the static analysis rules and regulations, if you see the code, it is as per the requirement it runs. The static analysis, even though everything is right, it shows something went wrong in the static analysis too. That kind of things also you can predefine set when you are creating your static analysis automated program. You can rectify all those things and you can avoid, and because whenever it's keep on appearing, this is the mistake, is that you can ignore it. So that is a false positive that you can fix up on your own. And this code I picked it from the C# code. This is again FXCOP report. Once we executed this code, we have got the list of bugs that we got to fix. So I picked only 3 out of this. If you see that the third statement, public partial class default CA 1707. If you see that here CA, it says remove the underscore from type underscore default. So there is a naming conflict that you can go and fix it. And the other one is CA 1820. That is the comparison of string, that is the replace call to string operators. That is the 1, 2, 3, 4th line I am referring to. Replace the call to string operators. You have to use string dot is null or empty, that you can fix it. And then the final CA 1704, that is in your 3, 4, 5, 6, 7th row, CA 17, that is the in method. It's clearly giving the what to be done and what not to be done, and everything is there, so you'll be able to go and fix it. So when you run, you get the quick feedback of these many errors, you'll be able to fix it. And I picked this code specifically to showcase, that is, if you see the connection, I have just put it one, I highlighted with a red circle. There is a connection open there. If you see that everything is disposed, all the command timeout, everything, if you see that disposed, sorry, but the connection is still open. That's where the FXCOP will find out and tell you there is a memory leak there. So these kind of bugs you'll be able to fix it then and there. This is very important bug that FXCOP will allow you to find. And the FXCOP is the code analyzer. It is not only help you to memory leaks or these kind of things. It will even help you to the low level of web application HTML tags and all that. So you'll be able to integrate with the IDE, and then you'll be able to run through FXCOP and get the list of issues like this, and you can quickly fix it up. So the conclusion, I'm in the last slide right now. So to conclude this, just not only the reviews and the verification, the functional testing is just not that is sufficient, because we have so many issues that is always hidden, as I mentioned in the earlier slides. That is reliability, security, maintainability. All these issues are always we have to focus and fix it in the early stage, because these are all the issues cost us bigger prices. We have to avoid it before in hand to see that we are like gaining the confidence from client, not losing the confidence from client. We are not increasing the cost of the project. We are having a good seeing the profit or margin of the project. And then we will also see that this is not going with the iteration of reworks when it's happening. That is really reduce the quality and reduce the increase the cost of the project. So to summarize, definitely these kind of techniques will allow us to deliver the good quality of product. Thank you very much for listening to me. I'll move ahead with question and answer.
Thank you so much, Malini. And if I may ask you quickly, how much time do you have to take up the questions?
I can take a couple of them for sure, and I will definitely email them, and I'll be in touch with them in
All
whatever the possible way later.
Okay, I'm assigning you around 3 or 4 questions. Please, you will find
Yes.
them in your questions window.
Okay. Alright, first one, please help us in elaborating more on static analysis, like finding out unusual bugs. That I have to definitely, take up with Raj Suresh Mad. I think I'll be sharing my email ID because that's going to be a very lengthy discussion. How do we find out unusual bugs? I can tell you, Raj, we can just take up one other offline session with you if at all you are interested. I'll go through with you. And for unusual bugs, it's just not the memory leaks itself. There are security threats you will be able to find out. And when I say data flow analysis, that's where some static analysis tools will help us to fix the unusual bugs. That's a very crucial area of fixing up in the, because that's the designing stage of the data flow, right? That's where the security threats and the memory leaks are every factor that is involved there. So we have to get there. I will definitely touch base with you. What if one of the value 1 and value 2 are negative? What, Raj and Nagendra Kumar, what if one of the value 1 and value 2 are negative? I think that the question is not complete for me. Cannot understand the pros of PyChecker, how far it is effective. I think we never discussed about any pros and cons of the PyChecker, and the PyChecker will give you, I think I just go over the, sorry, I'm just going back to the PyChecker. We never discussed about the pros and cons because this is a huge area. Again, we have to this. I was just talking about the code. By seeing this code, we will not be able to find any error, because if someone is giving me this code, I'll not be able to immediately tell what is wrong. Even import says, I'll say, okay, if it is there, how does it is going to make a difference? I'm just importing a module. How does it? But the PyChecker will tell you the why we shouldn't be importing if at all we are not using. And then if you see the slide particularly, using a format string that is not even matching the arguments, that is also one other thing. Unused variables, if at all anything is there, whether it is a global variable, whether it's a local variable, how it is being defined, how the arguments are passed, how the parameters are used, all these things, you no need to spend your time to step by step go through and all that. These are all predefined set of rules that is already defined within the PyChecker, but definitely it will give you. Cons, as I mentioned, it is a time consumed whenever you're doing this kind of analysis, static analysis. It's a time taken. Definitely for your program, for your output, there are few rules you can ignore, few rules you cannot. But most of the time, we will not go with the false positive. That's what I told you. You have to go back and fix up the false positive. These are all the set of rules. I'm not going to look at it. These are all the rules that's supposed to execute, and I want to see that is being fixed in the early stage of my code deliverables. In that way, definitely the PyChecker for the Python, it is best to help you out, to fix up all the minor level to medium level of mistakes that what generally we make. And I'm going to the what are all the C# code review tools? Are there any free versions as FXCorp is, yes, FXCorp comes with the IDE itself nowadays, and it is not only allowing you to that's what I mentioned, it's just not allowing you to set the rules and regulation. It's much more intelligent now. I haven't gone through the recent one, but the recent past one, it is very very easy to use, and it did capture a couple of unusual bugs. I think Raj Suresh, if you're there, you can explore the FXCorp and you can read out what kind of unusual bugs that can capture, that you will also get to know. And Shrikant, yes, it is a free tool. You can use it, and whenever you guys are going for a compiler, certain compilers, in fact some compilers do offer static analysis features. It's worth checking before you are purchasing it. And this FXCorp is like kind of help you very helpful in the component level of testing for sure. Can we integrate static analysis tools with any of the build tool like Jenkins, Milind? Yes, definitely. I think I missed out the point where I really want to make this. Thank you so much, Milind, to bring in that. Definitely we can, these days all the build managers, when they say that the cycle, right, the code save build, these cycles are going with the static analysis tools, and they are integrating the static analysis tools with build management tools, definitely, yes. And I'm going back to the Raja Nagendra Kumar. What if one of the value 1 and value 2 are negative? I'm sorry, I'm not able to understand, but definitely you can drop me a message in detail. I'll take it up. Any other question that I have to look into at this time?
Thanks, Malini. No, I think that will be all. I haven't received any other questions, so maybe, as you said, if attendees do have any questions, they can always take it up with you offline, or else they can come and post their queries on our discussion forum.
Definitely, I'll do that. Thank you. Thanks everyone.
Thank you so much, Malini, once again, and thanks everyone for your fair participation. And you will find today's recording session on techgig.com by tomorrow afternoon. And please feel free to come and post your feedback, suggestions, any queries that you might have from today's webinar. Thank you so much.
Thank you.